This is the demo for College Algebra Lesson 8. We're going to talk about complex numbers today. If I want to find the solutions to the quadratic equation x squared plus 1 equals 0, which is what we just looked at graphically, and it didn't have any solutions. It does not cross the x-axis, but I can still go through the motions of using the quadratic formula. So in this case, a is 1, b is 0 because there's no x term, and c is 1. And so I'm going to plug into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b is 0. So I have 0 plus or minus the square root of b squared, which is 0, minus 4 times a times c all over 2 times 1. So the square root of negative 4 over 2. Ooh, okay. Then we have a square root under a negative, and that is not a real number. So we're going to leave it like that for now. An equivalent equation, x squared plus 1 equals 0. If I wanted to solve it by using the square root property, I can move the 1 over to the other side, so I get x squared equals negative 1. Just by subtracting 1 from both sides. And then I can square root both sides. So the square root of x squared equals the square root of negative 1. So we would get the absolute value of x equals the square root of negative 1. So x is plus or minus the square root of negative 1. Oh, I forgot the plus or minus up there from the previous step. Okay, so what do? We again ended up with a square root under a negative, which is not a real number. There is no real number that you can square to make negative 1, right? Because when you square a number, that means multiply it by itself. So if I take a number times itself, if that number is positive, we're going to multiply it times itself, which is another positive. Positive times positive is positive. Not negative. You can't make a negative with two positives. But if I square a negative number, that would be a negative times a negative, which is also positive. So again, there is no real number that you can square and get a negative answer. So what do? Well, mathematicians decided to invent a new number system called the complex number system that provides us a solution to the equation and other equations like it. Okay, so the definition of the square root of negative 1. We're saying, well, there is no real number that you can square and make a negative 1, but let's just imagine what would happen if there were a number that you could square to make negative 1. So that would be the square root of negative 1, and we're going to call it I. So now our solutions are going to be plus or minus I. Okay, when you're solving quadratic equations that do not cross the x-axis, we use the following property often. If you're trying to take the square root of a negative number, rewrite it as the square root of negative 1 times k, and then the square root of negative 1 will be replaced with an I. So for example, the square root of negative 49, I would rewrite that as the square root of negative 1 times 49, and the square root of negative 1 times the square root of 49. And then the square root of negative 1 is I, and the square root of 49 is 7. So this is 7I. Square root of negative 8. I'm going to rewrite this as the square root of negative 1 times 4 times 2. And then square root each component separately. So the square root of the negative 1 is an I. The square root of the 4 is a 2. And I can't do anything else with that root 2. And then by convention, we usually put the I, like you usually put a letter after the number. So this will be 2I root 2. You can do multiplication in any order. So this answer is correct. It's just a convention that we usually put number then letter when we're writing things that have a product that has a number and a letter. Okay, C, I'm doing negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2. This looks like a result from a quadratic formula. Let's see what happens. I have negative 2 plus or minus the square root of 4 minus 12 all over 2. So negative 2 plus or minus root negative 8 over 2. And then I'm going to rewrite that negative 8 as, you know what, I'm going to write it up here. Negative 2 plus or minus the square root. I'm going to take the negative and make it a negative 1, and then rewrite the 8 as 4 times 2. And that's all over 2. This becomes negative 2 plus or minus 2i root 2 all over 2. Break it into two fractions, so I have negative 2 over 2 plus or minus 2i root 2 over 2, and then reduce. So I have negative 1 plus or minus I root 2. And then finally, I squared. Okay, finally we have I squared. So I squared, well, that's the square root of negative 1 squared. And when you square a square root, they cancel. The square and the square root cancel, so we get I squared is negative 1. Number 5, if a radicand is negative, write the radical in terms of I before you do anything else. So get rid of the negatives under the radicals first by pulling out i's. So this is going to be the square root of negative 20. I'm going to rewrite this as negative 1 times 20. And the square root of negative 5, I'm going to write that as the square root of negative 1 times 5. Square root of the negative 1s give me i's. So this is going to be I root 20 times I root 5. And I times I is I squared. And square root of 20 times square root of 5 is square root of 20 times 5. So this is I squared is negative 1 times the square root of 100. That's negative 1 times 10, which is negative 10. Number 6, quadratic equations with non-real solutions. So now I'm going to try to solve this quadratic equation. I'm going to use the quadratic formula. I may need to invoke what I now know about imaginary numbers. So x equals negative b, or the opposite of b, so that would be 8, plus or minus the square root of b squared, so that's 64, minus 4 times a times c, all over 2 times a. So that's 8 plus or minus the square root of 64 minus 4 times 3 times 7 is 84, all over 6. So that's 8 plus or minus the square root of negative 20 all over 6. I'm just going to simplify that radical. So I get 8 plus or minus the square root. I'm going to rewrite that negative 20 as negative 1 times 4 times 5 all over 6. So I chose that. If there's a negative, you're always going to make a negative 1. And then I looked at the 20 and I looked for perfect square factors. The only one is 4, so I wrote that as 4 times 5. Square root the things you can square root. So this is now 8 plus or minus. The square root of negative 1 is I. The square root of 4 is 2. I can't do anything with the square root of 5, and this is all over 6. I'm going to break this into two separate fractions, 8 over 6 plus or minus 2i root 5 over 6. And I just changed the order of the multiplication here. It's just a convention to put the letter after the number. And then reduce each of those two fractions. So 8 over 6, that would reduce to, let's see, 2 goes into both of those, so 4 over 3, plus or minus I root 5 over 3.